back. Here I am going to explain clean room technology. Actually, this is a part of module 3. So, clean room technology actually it's very useful for pharmaceutical production, even hospitals, and it has got many applications. So, definition of clean room technology as per the International Organization for Standardization standard 146441 as a room in which the concentration of airborne particle is controlled and which is constructed and used in a manner to minimize the introduction, generation and retention of particles inside the room, and in which other relevant parameters, for example temperature, humidity, pressure, are controlled as necessary. So this is achieved firstly by supplying it with exponentially large quantities of air that has been filtered with high efficiency filters. This air is used to dilute and remove the particles and bacteria dispersed from personnel and machinery within the room, and to pressurize the rooms and ensure that no dirty air flows into the clean room. Secondly, a clean room is built with materials that do not generate particles and can be easily cleaned. Finally, clean room personnel use clothing that envelops them and minimize their dispersion of particles and microorganisms. The history of clean room. It is clear that the first clean room were in hospitals. Lord Leicester's contribution to history was his realization that bacteria cause surgical wound infection. He thought that the elimination of bacteria from the operating room should prevent infection. This was the scientific basis for the first clean room. In the year 1860, Lister dramatically reduced the infection in his operating room by use of an antiseptic solution. Actually, he used carbolic acid that killed bacteria. He used this on the instruments, the wound, and the surgeon's hands, and he attempted to prevent airborne infection by spraying carbolic acid into the air of an operating room. So, by the early 1960s, the performance of turbulently ventilated rooms were known. In 1960s, Blows and crew attempted to obtain a downward piston of air from an air diffuser fitted over the entire ceiling in an operating room. In 1961, Howard and he attempted to perfect the piston effect of the downward flow of air. He restricted the airflow to a small area and hence improved the downward flow of air. And the development of first clean room for industrial manufacturing started during the Second World War. This was mainly in an attempt to improve the quality and reliability of instruments used in guns, tanks, and aircraft. So the need for clean rooms. The clean rooms are needed because people, production machinery, and the building structure generate contamination. People and machinery produce millions of particles, and conventional building materials can easily break up. A clean room allows manufacturing to be carried out in a clean environment. So, the use of clean rooms are diverse. Some of the applications are listed here. So, clean room applications can be broadly divided into two. One, those industries where the dust particles are a problem, and their presence even in sub-micrometer size may prevent a product functioning or reduce its useful life. Manufacturers who require the absence of microorganisms as their growth in a product could lead to human infection. The health care industry is a major use of clean rooms, as microorganisms or dirt must not be injected or infused into patients through their products. Hospital operating rooms are also use clean room technology to minimize wound infection. Coming to the types of clean rooms. So, clean rooms have evolved into two major types and they are differentiated by their method of ventilation. These are turbulent ventilated and unidirectional flow clean rooms. Turbulently ventilated clean rooms are also known as non-unidirectional. Turbulently ventilated room receiving clean filtered air through air diffusers in the ceiling. This air mixes with the room air and removes airborne contamination through air extracts at the bottom of the walls. Contamination generated gets mixed with the filtered air on personal movement. Here, clean and unclean pockets coexist. It is economically initially, but require large air handlers, which leads to more running costs. Unidirectional flow clean rooms were originally known as laminar flow clean rooms. High efficacy filters are installed across a whole ceiling and these supply air. This air sweeps across the room in a unidirectional way at a speed of around 0.4 meter per second and exits through the flow, thus removing the airborne contamination from the room. The unidirectional type of clean room uses very much more air than the turbulently ventilated type and gives superior cleanliness. Here, the spread of contamination minimized, clean air in whole space, so personal movement does not affect the environment. It is very expensive initially. It requires small air handlers, hence low running cost. So, what is clean room technology? Clean room technology can be divided into three broad areas. First one is clean room design and construction. So, wherever, for example, a pharmaceutical industry, first they have to design a clean room and construct it. Second one is clean room testing and monitoring. Once clean room is installed, it should be monitored continuously for its performance. Clean room operations. So, clean room will be operating for many purposes like monitoring the room conditions, entry of people, machines and materials, clean room disciplines to avoid contaminating the product, clean room garments. So, there should be specific dress code for clean rooms including gloves, masks, etc. Clean room cleaning and cleaning equipment should be a protocol should be there. So, clean room design and construction actually stand as per the standards, and the construction material should be used in such a way that the dust particles has to be minimized. Then clean room testing and monitoring, testing that the new room performs as designed, and testing to ensure that the room continues to perform as designed. So, coming to clean room classification standards. The most world clean room standards including ISO standard 146441 was federal standard 209. Clean rooms are classified by the cleanliness of their air. The most easily understood classification for clean room is the one used in the earlier versions A2T of Federal Standard 209 of the USA. This classification has been suspended by the last version of Federal Standards E and now by the International Standard ISO 14644-1. The ISO 146441 standard has been adopted by all countries in European Union and is now being adopted by other countries. ISO standard 14641, the International Organization for Standards, is developing a series of clean room standards. These cover a wide variety of important clean room issues such as design, testing, operation, and biocontamination. So the first document published in 1999 is ISO 14644-1 and entitled Classification of Air Cleanliness. This gives the clean room classification methods. ISO standard 14641 here selected classes are there: ISO class 1, class 2, class 3, class 4, class 5, 6, 7, 8, and 9, and maximum concentration limits are given. So as per that, the standard has to be maintained. Pharmaceutical clean room classification. Clean rooms used for pharmaceutical manufacturing have their own standards. The two most widely used are those published by the European Union and the US. European Union Guide to Good Manufacturing Practice. The most recent pharmaceutical standard used in Europe come into operation on January 1997. This is called the Rules Governing Medicinal Products in the European Union, Volume 4. Good Manufacturing Practice, Medicinal Products for Human and Veterinary Use. It is often called the European Union Guide to Good Manufacturing Products. So, coming to this European Union Guide to Good Manufacturing Practice, for the manufacture of sterile medicinal products, for grades of airborne cleanliness are given. The airborne particulate classification for these grades are, so like grade A, B, A, C, A, D. So the number of maximum permitted number of particles equal to or above, so are given as per the table. So European Union Guide to Good Manufacturing Practice. Microbiological monitoring is also required to demonstrate microbiological cleanliness of the clean room during production. The recommended limits are different classifications are A, B, C, D, and the recommended limits of microbial contaminations are given in the table. The International Confederation of Contamination Control Societies. The ICCCS is a confederation of societies that have an interest in clean room technology. The present members is as follows. It includes Australian Contamination Control Society, Association of Load Studio Control Contamination, Italy. So then there are different agencies and different countries involved in this. A current list of secretaries of member societies and their contact information is available on ICCCS website. So coming to the filters used in clean room. So high efficacy air filters are very much needed for filtering the air in a clean room. Clean room filters would be normally be better than 99.97% efficient in removing particles greater than and about 0.3 m from the room's air supply. These filters are known as high efficacy particle air HEPA filters, although ultra low penetration air filters which have an even higher efficiency are used in microelectronic fabrication and similar areas. Most clean rooms use HEPA or ULPA filters. In the lowest standards of clean rooms, they are not essential. In an ISO class 8 room, bag type filters with an efficiency near to 90% against particles 0.5 m are often used. In most clean rooms, HEPA or ULPA filters are installed at the point where the air is discharged into the room. Auxiliary clean rooms. Adjacent to the main production clean room, there will be other clean rooms. Clothing change area. Rooms used for changing into and out of clean room clothing vary in design. The number of rooms in the change area and whether these rooms are divided into two or more zones by crossover benches. Sometimes lockers for outdoor clothing and valuables are provided outside the change area and sometimes inside also. Material transfer area. This is another important area. This allows materials to be transferred into the clean room with the minimum of contamination. The material transfer airlock will minimize the transfer of contamination from the outside corridor to the production room. Airlock doors are often interlocked to ensure that both doors cannot be opened simultaneously. This minimizes the direct exchange of air from the outside corridor to the production room. Containment rooms. Clean rooms are used to prevent the contamination of articles produced in the room. However, some manufacturing processes produce toxic chemicals or dangerous bacteria, and these must be contained in a clean environment. So, the biotechnology industry, where rooms are required to contain the genetically engineered microorganisms. Microbiological laboratories dealing with the dangerous microorganisms require that the personnel working in them or the people passing near them are not infected. Some other kind of industries like hormone production industries that should be extremely free from contaminating organisms. Clean room testing and monitoring. So even though clean room is installed, it should be tested and monitored periodically about its performance. The initial type of testing is to establish that clean room is working correctly and achieving the contamination standards that it has been designed to fulfill. These standards are laid in ISO 146441. It is necessary to regularly check the rooms at the time interval set by ISO 14644 to ensure that the room continues to comply with the standards. So, clean room testing. The most important part of this clean room is it has to be tested periodically. So, tests start with the room air supply and extract is whether it is working fine. Once it is passed, air movement between areas has to be checked. Then filters installation leak test has to be performed if any leakage is there or any particulate matters enters. Containment leak test has to be performed. Air movement in room has to be checked. Particle count has to be done. So finally it should compliance with the compliance with this cleanliness or the standards. The most important test used to ensure a clean room is working correctly is a count of the airborne particle. Airborne particle counters, an instrument known as particle counter, is used to count and size particles in air of a clean room. This is often called a single particle counter to distinguish it from a photometer used to test filter installation leakage. A particle counter both counts and size particles in the air, whereas a photometer simply measures the mass of particles. A particle counter is an essential tool for testing and running clean rooms. Good second-hand models are often available at a modest price. So clean room should be without. So no clean room should be without this. And clean room persons are important source of clean room contamination. Almost all microorganisms found in a clean room come from personnel, and they are also major source of particles and fibers. It is therefore necessary to ensure that minimum of contamination is generated and transferred by personal activities. By observing certain disciplines, contamination of the product can be minimized. Clean room, first of all, clean room clothing. Large amount of contamination are dispersed from people in clean rooms. Special clothing is therefore worn in all clean rooms to control the particles and microbiological dispersion from people, and hence the contamination within clean rooms. So clean room mask and gloves has to be aired. So people expel large numbers of saliva droplets from their mouth when they sneeze, cough, and talking. These droplets contain salts and bacteria, and is actually necessary to prevent them causing contamination in the clean room. Wearing a mask over the face normally does this. So there are reference clean room technology.